Hi, in this video, I will be showing you one more example of reversing the order of integration. Set up the integrals for both orders of integration, then evaluate the double integral using the easier order, double integral over d y square e to the xy dA, where d is bounded by y equal to x, y equal to 4, and x equal to 0. Let's first find out the region of the domain. We'll graph the domain. Domain is made up of the lines y equal to x, which is as shown in the graph, and y equal to 4 and x equal to 0. So it's bounded by these lines. So the region of the domain of this region given is the spot, which is shaded in yellow. So this will be the region. Now the first order of integration we can consider as given in the problem. So if we have to see where the two graphs meet, as y equal to x and you are given y equal to 4 there, then x should also be equal to 4. So they meet at the point 4 comma 4. The line y equal to x and y equal to 4 meet at 4 4. So if you give the order of integration as given in the problem, and if you take x fixed, x equal to 0 to 4, and y runs from this value to this value. So that will be from y equal to x to y equal to 4. So this is one order of integration, that is e to the y square, e to the xy, dA. Here you are integrating with respect to y first, and then you are integrating with respect to x, because the outer integral is with respect to x. That is a definite limit. So this is one order of integration. Without changing the region, without changing the domain, you have to reverse it, because if you keep the problem the way it is, then it will be very hard to integrate. So you have to integrate y square e to the xy with respect to y first, which is the inner integral, which becomes very hard to integrate, right? So you have to apply integration by parts, and the problem becomes very complicated. So instead, if we reverse it, let's see how we reverse it. So reverse the order of integration without changing the domain. So you are given, we have to still keep the domain as is. So the domain is still the same. So now we have to keep the y fixed. Y limits are definite, and we have to give the varying limits for x. So x runs from 0 through y. So the reversed order would be the domain, that will be y fixed, y less than or equal to 4, 0 to 4, and x lies between 0 to y. This will be the reversed order. So if we use this easier one, then the problem would be easy to integrate. So the question is asking us to set up the integrals for both orders of integration, which are these two. Now we are going to use the easier one to integrate. So here I have shown the picture again, and then how we want to integrate. We want to keep the y, the outer limit, which are fixed limits, which is 0 to 4. And then the inner limits are for x, with x varying from 0 to y. Now we will start integrating the inner one first. So keep the outer integral, outer y as is. Integrate with respect to x. So that means y is a constant, so y square. Then whenever you integrate e to the xy, so for example, if you do e to the 2x with respect to x, integrate that, you get e to the 2x divided by 2. E to the 2x divided by 2. So when you integrate an exponent, e to the exponent with one constant coefficient, then that constant will come down. So that is how we integrate. So here, when you integrate with respect to x, y is a constant. So you're going to write e to the xy divided by y because you're integrating with respect to y. So here the y is a constant coefficient for x, so that comes down. So now you want to integrate, now you want to give the limits which are x equal to 0 through y. So here y inside can be crossed out. So you have outside with respect to y. So what we have here is integral y varying from 0 to 4, and then we want to plug in the limits 0 and y, upper limit first, and that gets x gets replaced by y. So e to the y times y, which is e to the y square. Then you are going to plug in x equal to 0. That will become e to the 0, which is 1. So 1 times y. So you will have at the lower limit for x equal to 0, you have y. Then you are going to integrate that all with respect to y. Maybe we want to split this integral into two parts, which is integral 0 to 4 y e to the y square dy, one integral. The other one can be easily integrated, which is integral of y, which is y squared over 2, between the limit 0 and 4. So here we will call it just I1, and we can actually plug in the values here, which is 4 square over 2, 16 over 2, that will be 8, and at the lower limit it is 0. So we will evaluate this I1, the first integral, by regular substitution method. So y times e to the y squared dy, we have to get to this step. So we'll call it 3, and then we'll plug in what this I1 is. So for this integral I1, we will plug in y square equal to, say, u. Then 2y dy would be du. We can also change the limits. So for y and u, y equal to lower limit 0. So u, which is y square, which is 0 as well. Then 4, u, which is y square, which will be 16. So this integral for the new limits will become u equal to 0 through 16. Then we have e to the u. Then you have y dy. Y dy is du over 2. That is du over 2. So which will be half of e to the u between the limit 0 and 16. So it is e to the 16 minus e to the 0, which is 1 over 2. And this is just the value of I1. Now we are going to plug this into step number 3. So substitute this into step number 3. So substituting this value of I1 into I in step number 3, we get I1 gets replaced by e to the 16 minus 1 over 2. Then we already have that second term, which is negative 8. If you simplify that, you get e to the 16 minus 17 over 2. So in these problems, the main concept is that you cannot change the domain, but we have to work with the easier variable, easier limits to integrate the problem in an easy way. If we had set the problem the way it was given, the problem would have been very difficult. Now, because of the change of the reversing the order of integration, we were able to do this integration in an easy way. Hope this video helps.